Hello students, good evening. Today we are going to discuss a new topic from this first chapter, some basic concepts of chemistry. So it's a very interesting topic today we are going to discuss, and it is also an important topic. So today we will be discussing about the concentration terms. Before going into the topic, just you can read the full year course that we are providing. So you can see that we will be providing the PDF materials, that means the complete modules of each chapters or each lessons along with the question bank, and we are conducting 25 major tests as per the NTA pattern, and there will be query solving and lessons, assignments, etc, etc. Okay, so dear students, this is the mind-blowing offer for you all, that you can crack JEE or NEET with the top class faculties with an enormous discount amount of just rupees 490. Guys, this is a never miss chance for you. Okay, now also if you are new to this channel, you can subscribe our YouTube channel. Okay, we are providing free classes regularly. So you can subscribe to our YouTube channel, and you can earn more knowledge and learn more concepts without any payment, etc. It's all for free for you now. Okay, yes. So this is all about me. Okay, my name is Roshan, and I'm MTech postgraduate. I have won the National Olympiad, and in the same field in NEET and JEE coaching, I have 6+ years of experience and guided more than 1 lakh of students. Okay, yes. Now dear students, we are going to discuss about the concentration terms. Okay, so concentration terms is very important topic. Not only from this chapter, you have to be well versed with concentration terms when you are dealing with the chapter solutions, when you are dealing with the chapter chemical equilibrium, redox reactions and all. You must have the knowledge of the concentration terms, right? Okay, now let's move on to the chapter. So here we are going to discuss, actually in this section we will be discussing about the 4 major concentration terms that you have to study. The very first one is about molarity, then we will study about molality, then we will study about the normality, and then we will be studying about the mole fraction. So these 3 major concentration terms will be discussed in this lesson. So let's start with the molarity. Dear students, so you know that we normally use all these concentration terms with regards to the solutions, right? Because we must know the strength of the solution. For understanding or for determining the strength of the solution, we normally uses concentration terms, right? So if we use molarity or molality or any other concentration terms, that concentration terms particularly indicate or give a picture about how the solution or how the concentration of the solution is. You have learned that there is 2 types of solutions, or there is 2 types of concentration. We normally call them concentrated acid or dilute acid. So what does that mean? What is the difference between concentrated acid and dilute acid? It simply means that the concentration of that particular acid is very more or very high. That means the solute is very high and the solvent is low. If in such cases, we call them as concentrated acid. If the solvent is very high and the solute particles is low, then we call the acid as dilute acid. Let's consider this one. See, if you consider a solution, let's take a solution. See, if you consider a solution, we know that a solution consists of 2 components. One is a solvent and the other is solute. So you have to understand that the ratio of solvent with solute with solvent determines the concentration of the solution. If in a solvent the concentration of solute is very high, or the number of moles of solute is high, that means the solution itself is highly concentrated. Whereas if the solvent number of moles of solvent is high, then the concentration is said to be very low, or we call that solution to be a dilute. Okay. So what is molarity? Molarity is simply the number of moles of solute in 1 liter of solution. Okay, what is that? It is moles of solute in 1 liter of solution. Okay, so can you represent that in an equation? Yes, of course. Molarity is equal to number of moles divided by volume, and volume should be considered in liters. So 1 molar solution means what? What do you mean by 1 molar solution? 1 molar solution means 1 mole of solute in 1 liter of solution. 1 mole in 1 liter of solution. What do you mean by 2 molar concentrated solution? That means it consists of 2 moles of solute, 2 moles of solute in 1 liter solution. In 1 liter solution. This is what you have to understand regarding molarity. Okay, so what is molarity? Molarity means number of moles of solute by volume of solution in liters. Now I have given you 3 equations. Let's focus here. I have told you that molarity M means number of moles by volume in liter. It is the simplest form. Now if you are not given the number of moles, then we can use, or we know the equation or the formula to find out the number of moles. That we know that number of moles is equal to weight of solute by molar mass of solute. Here the number of moles is in regards with the moles of solute. Okay, so always remember that I use the number 2 for solute and I use the number 1 for solvent. So there will not be any confusion regarding that. So we know that we are discussing about the solution. So solution consists of 2 components. One is solvent, the other one is solute. So whenever I use 2, that indicates the solute, and whenever I use 1, that indicates the solvent. So here we are discussing about the number of moles of solute. So in order to find the number of moles of solute, we know the equation that weight by molar mass will give us the number of moles. The number of moles of solute equal to W2 by M2. So I can substitute that over here. So molarity becomes molarity equal to W2 divided by M2 into volume in liters. Say in certain question, if the volume is given in milliliter, then what you have to do? You have to convert that milliliter to liter. For that you have to divide the volume by 1000. So our equation can be written like this: W2 into 1000. That means when you divide the volume by 1000, that 1000 will come to the numerator. So W2 by 1000, W2 into 1000 divided by M2 into V in ml. So if the question is given in terms of, in the question the volume is given in terms of ml, then you can use the third equation. Okay, otherwise you can use the first equation or second equation according to the values given in the question. If the number of moles is given and volume is in liters, you can directly use equation 1. If number of moles is not given, you can find out the number of moles by using the formula weight by molar mass, and you can use, for that you can use the second equation. If the volume is given in ml, then you can use the third equation. This is all about molarity. Now let me clear one point here. Here from the first equation you can see that molarity equal to number of moles divided by volume. So what do you mean by number of moles? You can calculate the number of moles as molarity into volume. So number of moles of solute can be found out by multiplying molarity into volume. So molarity into volume will give you the number of moles. Hope this is clear, students. So we will move on to the next one. See, this is very important note, that just see that molarity of a solution only depends upon the temperature. It depends upon temperature. You know why? Because let's see here. Here you can see that molarity is equal to number of moles by volume, right? If the temperature is increased, what happens? If temperature is increased, volume also increases. You know that the molecular forces of attraction. So as long as you give the thermal energy, the molecules will set apart and they will move freely. That means the volume get expanded or the volume get increased due to application of temperature. That means if volume is increased, then obviously there will be a change in the value of molarity. So the concentration term molarity depends on what? It depends on temperature. So you have to keep this point in mind. Whenever there is a concentration term that is related to volume, then whenever you changes the temperature, the volume changes and when the volume changes, obviously the molarity, the value of the molarity also changes. Now let's move on to the next one. The second one is molality. See, what is molality? You can see that molality is equal to the number of moles. Normally we represent molality by small m and molarity with capital M. So what is molality? Molality is number of moles of solute. So number of moles of solute by mass of solvent. So mass of solvent I represent it by W1. So mass of solvent in kilogram. So you have to be very clear about the difference. See, in the molarity, while finding molarity, we found that number of moles of solute divided by volume of solution. It was the volume of solution. But in the case of molality, the number of moles of solute divided by it is the weight of solvent. So it is the weight of solvents. You have to be very clear regarding the formula. So number of moles of solute divided by weight of solvent, and weight of solvent should be expressed in kilogram, right? So let's see this. So if the molality, I can write here molality equal to number of moles by weight of solvent in kilogram. See, if the number of moles is not given, then we know that how to find the number of moles. So we know that weight of solute by molar mass of solute into weight of solvent in kilogram will give us the molality. And if the mass is given in grams, then what we have to do is that we have to convert that mass into kilogram. So in that case, we have to divide the W1 by 1000, divide W1 with 1000, and then the 1000 will go to the numerator. So the equation can be written like this, that is W2 into 1000 divided by M2 into W1 in grams. So if it is given in gram, this is the formula you have to use. So molality, for molality also we have discussed 3 equations. So you have to very much careful about molality. Okay, now let's see here, one note is there in the next slide that, see, molality of a solution does not change with temperature. Can you explain why it does not change with the temperature? Yes, because see here, the molality equation, if you consider the molality equation, M is equal to number of moles of solute by a weight of solvent in kilogram. So we know that weight of the solvent does not change with temperature. Weight is a constant one, and it does not change with temperature, but volume changes. So here molality does not change with change in temperature. Molarity will change with change in temperature because it is related to volume. So whenever you change temperature, there will either be an expansion in volume or there will be a contraction in volume. So there will be a change in volume. So what happens if you are considering the concentration in terms of molarity, then it is temperature dependent, so it can be changed from one season to other season when the atmospheric temperature differs. But if you are considering the concentration in terms of molality, then you are on the safer zone, because as the seasons changes, the temperature changes, but the molality doesn't change. Molality will be constant because molality depends on weight of the solvent, and weight is independent of temperature. Okay, so that is what you have to understand here, right? Now this is a very important formula. See, from the mole concept or from the first chapter, you know that we study the concentration terms, but it is not, the direct concentration terms are not asked. Instead of that, they generally ask the interconversions of molarity to molality and to other concentration terms. So this equation or this formula is very important, So if you are given the density of the solution, normally the question will be asked in terms of density. So they will give you the density, and either they will give you molarity or they will give you molality. Either of the two will be given, and you have to find either molarity or molality. Either of the two you have to find. So in certain question you can see that density will be given, molarity will be given, then you have to find the molality. So that's how the question will be asked. Or in certain situations density and molality will be given and you have to find out the molarity. So this equation you have to by heart. And what is DSOL means? It means density of solution. Density of solution. What about M? Capital M is molarity. It's nothing but molarity. So what is M2? I have told you M2 is just 2 indicates the solute. So M2 means molar mass of solute. Molar mass of solute. And what about M? Small letter M? Small letter M indicates the molality. So this is a very important equation. You have to by heart this so that you can easily do the interconversion concentration questions. Okay, right. Now let's check this out. Calculate the molality of KCl solution prepared by dissolving 7.45 gram of KCl in 500 ml of the solution, and density is given. So let's check this out. Density is given as 1.2 gram per ml. Okay, ready. Now we have to find out the molality. You have to find out the molality. What all things are given? Yes, weight is given. Weight of solute is given, that is 7.45 gram. Okay. Molar mass we can find out. Molar mass can be find out, that is potassium means it is 39 gram per mole plus chlorine means it is 35.5 gram per mole. So 39 plus 35, 69, 74.5. Yes, we get the value as 74.5 grams. That is the molar mass of KCl. Now here we can find out, and the volume also given as, volume is given in 500 ml. Okay. Here we can find out the molarity, because in order to find the molality we have to know what is molarity in the density equation, right? So we will find out the molarity. Molarity is equal to number of moles by volume. Number of moles, how to find out the number of moles? Number of moles means weight, W2 by M2, right? So what's the equation? Yes, W2 by M2 into volume. Volume is given in ml, so I will use 1000 here. So what is the molarity? W2 is 7.45 into 1000 divided by molarity is 74.5 into volume is 500 ml. So we can cancel this 500 and 1000, goes in 2 times, and this can be cancelled. 7.45 goes into 10 will give you 74.5, and I can again cancel this and we will get 5. So 1 by 5 equals to 0.2. Okay, so molarity is equal to 0.2. Now what will be the answer? We know that density of solution is equal to molar mass into, molarity into molar mass of solute by 1000 plus 1 by molality. So let's give all the values here. So density is 1.2, molarity is equal to 0.2, molar mass is equal to 74.5 divided by 1000 plus 1 by molality. Okay, so here if you take this here 1.2 by 0.2, that means it is equal to 6, equal to 0.0745 plus 1 by m, that is 1 by m is equal to 6 minus 0.745. What is that? 6 minus 6.0000 minus 0.0745. This will be 5, 9, 9, 9 and 10. This 5, 5, 2 and 9.5. So it is nearly equal to 5.92. So what is molality? It's equal to 1 divided by 5.92. So molality equal to, its value nearly equal to 0.168. 0.168 molal. 0.168 molal. So this is the answer. Okay. So very interesting question. Now we'll move on to the next one. So calculate the molality of 3 molar solution of NaCl whose density is given. So molarity is given as 3 molar and density is given in 1.25 gram per ml. Okay, we have to find out the molality. So molality, we know that density is equal to molarity into molar mass of solute. NaCl is the solute, divided by 1000 plus 1 by molality. Okay, so molar mass is NaCl, that is 23 plus 35.5, right? Here it is sodium, mass of sodium is 23 plus 35.5, that means 58.5 gram per mole is the molar mass. So molarity is given as 3. So 3 into 58.5 divided by 1000 plus 1 by m is equal to 1.25. So 1.25 divided by 3, 1.25 divided by 3 equal to 58.5 by 1000 plus 1 by m. So this will be equal to, nearly equal to 0.41, nearly equal to 0.42. We can write it as 0.42. You need only required to take the closest value, no need of accurate value in chemistry calculations, right? So here you will be getting 0.058 plus 1 by m. So here we can subtract it, 0.420 minus 0.058. So here it will be 3, 11 and 10, that is 0.36. Okay, so here we will be getting 0.36 equal to 1 by m. So what is m? M equal to 1 by 0.36, that is equal to, the value will be 2 point something, right? Yeah, 2.79. We'll be getting the value as 2.79 molar. That's it. Okay, hope this is clear for you students. Yes. Now we'll be moving on to the next concentration term, that is normality, right? Okay. Yes. Okay students, so normality. So what is normality? Normality is nothing but it is defined as the number of gram equivalents of the solute in 1 liter of the solution and is denoted by N. See here, instead of moles we are using what? We are using gram equivalents. So the rest is same when you consider it with once you compare it with you compare it with the molarity. Okay, so molarity and normality is almost same. The only thing is, in molarity we use the moles of solute, but in normality we use gram equivalents of solute. So what is gram equivalence? That is what you have to understand. So gram equivalent is equal to mass of solute by equivalent mass of solute. So it is also similar to number of moles, right? In number of moles, how you find out the number of moles? We find the number of moles by mass of solute divided by molar mass of solute. Here we are using mass of solute by equivalent mass of solute. So now the equation is simple. We only have to understand what is equivalent mass, right? So equivalent mass is equal to molar mass divided by valency factor. Valency factor. So molar mass divided by valency factor, we generally use N to indicate the molar mass. So equivalent mass is equal to molar mass divided by valency factor. So the equation is so simple now. Gram equivalence is equal to mass of solute. It is similar to number of moles. Okay, that's what you have to connect. It is similar to number of moles, but it is not the number of moles of solute. There is a small difference, but whatever. Our aim is to find out what is the gram equivalence. So gram equivalence is equal to, you think about the number of moles, and number of moles means weight by molar mass. So here weight by gram equivalent or equivalent mass of solute. Okay, equivalent mass of solute. You should not use molar mass. You have to use equivalent mass of solute. So now we have to find out what is equivalent mass. Equivalent mass means molar mass by valency factor. Molar mass by valency factor. So you have to understand what is valency factor, right? So now think about this valency factor. Here we denote the valency factor as N. So what is valency factor means? If you are considering an acid, valency factor is equal to 1. If you are considering HCl, the valency factor is equal to 1. How did I know the valency factor is 1? Valency factor is nothing but it indicates the basicity of an acid. That means, what do you mean by basicity? Basicity just means number of H plus ions it can release. Number of H plus ions. Okay. Or it means acidity of a base. What do you mean by acidity of a base? Means acidity means number of OH minus ions it can release. And it indicates the total negative charge or positive charge of an ionic compound. If you are considering NaCl, the positive charge is plus 1 and negative charge is minus 1. So if you are considering an ionic compound, the valency factor of NaCl is 1 because there is only one positive charge and there is only one negative charge. Okay, so the valency factor is 1. If you are considering MgCl2, then what does that mean? The MgCl2 consists of Mg2 plus ion and 2Cl minus ion. So what is the valency factor here? You can take it as 2 from the cation and as well as you can take it as 2 from the anion, because here 2 negative charges is there, 2Cl is there, 2Cl minus is there. That means 2 negative charge. Okay. So valency factor is so simple that either it can be represented as the basicity of an acid, that means how much H plus ions it releases, or it can be represented as the acidity of a base, that means how much OH minus ions it releases, or you can consider it as total negative charge or positive charge of an ionic compound. Okay. So in the case of H2SO4, it is dibasic, that means it can release 2 H plus ions, and in the case of H3PO4, it is tribasic, it can release 3 H plus ion. And in the case of H3PO3, it can release 2 H plus ions. So there will be a confusion between H3PO4 and H3PO3. In H3PO4, we have written that the valency factor is 3. So I'll show you here in H3PO4, okay. This is the structure of H3PO4. That means there are 4 oxygen atoms and 3 hydrogen atoms. So hydrogen, hydrogen, hydrogen and double bond oxygen. Yes. This is the structure of H3PO4. Here you can see 3 hydrogen is attached to most electronegative oxygen atoms. That means these 3 hydrogens are acidic in nature. If hydrogen is attached to fluorine, fluorine, oxygen, nitrogen, like all these are highly electronegative atoms. If they are attached to highly electronegative atom, that hydrogen atom becomes acidic. Okay. Now let me show you in the next page that we are considering H3PO3. Okay. Let's consider H3PO3. What happens with H3PO3? And phosphorus and 4 bonds. We have 3 oxygen. So 1, 2, 3 oxygen. And we have 3 hydrogen. So 1 hydrogen I'll give here, the other hydrogen here, the other hydrogen here, and this is double bond. Okay. Now you can see that the electronegativity of hydrogen is 2.1 and phosphorus is nearly equal to 2.1. That means there is no much difference in electronegativity between hydrogen and phosphorus. So that means this hydrogen is not acidic. This is not acidic. It's non-acidic. That means from H3PO3 we can only find out 2 H plus ions or 2 hydrogen atoms which are acidic. Okay. So that's why its basicity is considered as 2H+. Basicity is considered as 2, right? Okay. Now, what about the acidity of a base? Acidity of a base means the number of replaceable OH minus ions. If you take a base and put it in water, then how much OH minus you are getting? So, if you are considering NaOH, then we will get N equal to 1 OH minus ions, and if you are considering CaOH twice, you will be getting N equal to 2, and if you are considering AlOH thrice, then you are getting N equal to 3. So, these are the valency factors. Okay. Now, this is the equation. Now, the equation is so simple that we have found out this is very important equation, that normality can be simply represented as normality equal to N. N means it is valency factor into molarity, valency factor into molarity. Okay. And normality in the contemporary manner, we can just represent it as normality equal to weight of the solute by equivalent mass of solute into volume of solution in liters. So, if you want to represent it in ml, if the question is given in ml, then you have to convert it into liters. So, for that we have to multiply 1000 in the numerator. We know all that, we have just completed that part. Okay, into volume in ml. Okay, and most important is this equation is very important. You have to study this. Okay, so normality is equal to number of moles into molarity. Okay, hope this is clear, students. Next, moving on. Here an interesting result. See, if a solution is having a normality of N1 and volume is V1 and it is diluted to a volume V2, okay, so that will have a new normality, that is N2, then the number of gram equivalent remains the same in the solution. So, here I need to explain some facts, that is, listen here, I have already told you that gram equivalents and moles are relatable, they are almost same, gram equivalents and moles. Okay. Now, let me explain about the molarity concept. So, if I take certain solvent, I add N solute, N1 solute. Okay, if I add N1 number of moles of solute to the solution. Now, what I did is that I add more water to the solution. I added more water to the solution. But the solute remains the same, right? If I dilute this, does the N1 changes? Does the N1 changes? No, N1 is present there, but the concentration is changing. Concentration changes, obviously when you are diluting, the concentration will change. Concentration changes because the volume is increasing. But from this figure and in this figure, the number of moles is same, number of moles of solute is N1 itself. So, if you add more water, there will no change in the number of moles. We know that from the molarity equation, we know that it is number of moles by volume in liter. So, what about the number of moles? Number of moles is equal to molarity into volume. So, in the first one, we know that M1 is equal to N by V1. And I can also write from this second container, we can write it as M2 equal to N by V2. That means here N is equal to M1 V1. And here also N is equal to M2 V2. That means in both the container number of moles are equal. So, we can write it as M1 V1 is equal to M2 V2. So, this is regarding the molarity. This is a very important relation. That means if you are taking a container of N moles of solute is present in that, and if you are diluting it to another volume, that means the molarity changes. Okay, the molarity changes, but what remains constant? The number of moles will be same in both the containers. So, you can derive this equation or you can use this equation and find out the given values. Either they will be asking about this molarity of the second solution, or they will be asking about the volume of the second solution. So, whatever they ask, you can just use this equation to find out the answer. Okay. Now, we will look into the previous slide. Here similarly, like M1 V1 equal to M2 V2, you can also use this here. N1 V1 equal to N2 V2. What is N1 V1? N1 V1 is gram equivalence of the first container, and N2 V2 is gram equivalence of the second container. So, gram equivalence of the first container and gram equivalence of the second container will be same, even though if you add more water to the solution. it is similar to number of moles, it will not change. So in that case you can derive this equation and you can write it as N1V1 is equal to M2V2. Similarly we have derived the equation in terms of molarity. M1V1 is equal to M2V2. So you can see it here. See, if a solution with molarity M1 and volume V1 is diluted to V2, so that new molarity is M2, then as the number of moles remains same in the solution, we can write as M1V1 is equal to M2V2. Okay. Now see this. Calculate the molarity M and normality of a solution of oxalic acid. What is oxalic acid? It is given, the formula is given COOH twice 2H2O. So since it is an acid, we just find out the basicity of this acid. That means how much H plus ions, basicity of the acid. That means the valency factor. The basicity of the acid is equal to 2. How did I get 2? Because here there is 2 molecules of COH. So one molecule of COH will give 1 H plus and the other molecule will also give 1 H plus. So in total we get 2 H plus ions. So the valency factor N is equal to basicity of acid, that is equal to 2. Now here we have to find out the molarity as well as normality. So in order to find out the molarity, we know that number of moles of solute by so here the weight is given, okay, here it is given in 500 ml. So we will use the other equation. What is the other equation? The other equation is W2 by M2 into W2 into 1000 by M2 into V. So W2 into 1000 divided by M2 into V. So what is W2? W2 is given as 12.6 into 1000 divided by M2. What is the molar mass of oxalic acid? We know that here there is 2 carbon. Here water, 2 molecule of water means it is 36 gram. Okay, that we got. Now C means 12. 12 plus 32, here 2 oxygen is there, so 32. 32 means 32, yes, 32 plus 12, that is 44. 44 plus 1, 45. 45 into 2, that is 90. So 90 gram plus 36 gram, that is equal to 126 gram. So here we will be getting 126 gram divided by 500. So if you cancel this, you will be getting 2, and if you cancel this, you will be getting 10. Okay, 12.6 into 10 will give you 126. So 2 by 10 means 0.2. So we got the molarity as 0.2, and we know that normality is equal to molarity into valency factor. Okay, so molarity is 0.2 and valency factor is 2, that is basicity of acid. So normality equal to 0.4. Okay, normality equal to 0.4. So that's all about this question, right? Okay students, the last one is regarding the mole fraction. So here we are going to discuss about mole fraction. So let's see, what do you mean by mole fraction? So I am taking a container here. So in this container, it consists of 2 components, A and B. Okay, so I have to find out the mole fraction of A. So normally we represent mole fraction by this letter, it is called as chi. For my convenience, I will call it as X. Okay, so what is mole fraction of A? Mole fraction of A is equal to number of moles of A divided by total moles present in the container, that is Na plus Nb. So here you can find out the definition as the ratio of number of moles of a particular component to the number of moles of the solution. So the solution is made up with A and B. So the what is the mole fraction of A? Mole fraction of A equal to number of moles of A divided by total moles of the solution. So what is the mole fraction of B? It is equal to number of moles of B by total number of moles of the solution. Okay, if say I am taking a container which consists of 3 components, that is A, then it consists of B and it consists of C. Let's say there are 3 components. Okay, so what is the mole fraction of A? Mole fraction of A is equal to number of moles of A divided by total moles Na plus Nb plus Nc. Similarly, what is mole fraction of B? Mole fraction of B equal to number of moles of B by Na plus Nb plus Nc. And what is mole fraction of C? Mole fraction of C equal to Nc by Na plus Nb plus Nc. Here, dear students, here there is an important concept, that is the total mole fraction will always be equal to 1. The total mole fraction will always be equal to 1. Similarly, in the case of the second case, mole fraction of A plus B plus C will be equal to 1. Okay, so this is what you have to study. So in such case, this will make our job a bit more easier, because once you have find out the mole fraction of A, then in order to find the mole fraction of B, you can just subtract it with 1. 1 minus mole fraction of A will give you mole fraction of B. Okay, similarly you can use it here. If you know the mole fraction of A and B, then in order to find the mole fraction of C, you can just use 1 minus mole fraction of A plus mole fraction of B, right? Okay. Now let's see this question. A solution contains 2.5 mole of ethanol and 7.5 mole of water. Calculate the mole fraction of each component. So we have to find out the mole fraction of C2H5OH, as well as we have to find out the mole fraction of H2O. Okay. So mole fraction of C2H5OH is equal to number of moles of C2H5OH divided by number of moles of C2H5OH plus number of moles of water. So number of moles of C2H5OH is equal to 2.5 divided by 2.5 plus 7.5. That is equal to 2.5 by 10, which is equal to 0.25. If the number of moles of C2H5OH is 0.25, then obviously the number of moles of H2O will be 0.75. How did I got? Because I know that XA plus XB should be equal to 1. If XA is equal to 0.25, then I can write it as XB equal to 1 minus 0.25, that is equal to 0.75. So by just looking at the value, you can answer it. So for the students who want to know the primitive method, then you can use that number of moles of H2O divided by number of moles of C2H5OH plus number of moles of H2O. So here it is 7.5 divided by 10, which is equal to 0.75. So I'll recommend this one because that's the easiest one. If you know the one mole fraction, then the other can be found out by just subtracting it with 1. 1 minus 0.25 will give you the mole fraction of B. Okay. Okay, students, this is a simple relationship between molality, moles and mole fraction. This one you have to by heart it for your benefit. Okay. So if molality is equal to number of moles of solute into 1000 divided by number of moles of solvent into molar mass of solvent. So here, which is equal to mole fraction of solute into 1000 divided by mole fraction of solvent into molar mass of solvent. So I have told you here N2 means what? Moles of solute. N2 is moles of solute. N1 means moles of solvent. What is M1? M1 means molar mass of solvent. Molar mass of solvent. And what about M2? M2 means similarly molar mass of solute. Whenever I give a designation as 2, then understand it is all about solute, and whenever I give a designation of 1, then understand it is all about solvent. Okay. Now what about X1? X1 is the mole fraction of solvent. And what about X2? X2 is mole fraction of solute. Okay, so this is all about the molality, moles and mole fraction. So that's all about the chapter today, students. So you might have understood what all things we are providing. So you can see it here, a concise one, that is we'll be providing with the structured course, and yes, with the free study materials will be provided to you, and there will be free test series and free question bank, free crash course access and assignments. Everything will be done. Okay, just we also have all the online modes of payment. You can do it in the one at a go, or you can part your payments into 1 or 2 times, so that can be done. Okay students, that's all for today's class, and hope the session is clear for you. Let me check your comments if you have any doubt in the comment section, so that we can clear it off. Yes. Okay students, so we are winding the chapter here. So hope every concept is clear for you. So we'll meet in the next session. Until then, take care and bye bye.